Hello, everyone. Today we're going to talk about IXL assignment 5EW, right fractions in lowest terms. Now, there are two common ways for doing this, and we're going to quickly review both. And then once we hop on over to IXL, I will make sure to show you both forms as we go throughout and do our example problems together. So the first method is by using the greatest common factor to simplify or reduce your fractions. You'll hear and you'll see the directions written both ways. Simplifying, reducing fractions, it's the same thing. We're trying to get the fraction as reduced, so as small as possible. We're trying to get it as simplified, so as simple as we possibly can. And one of those ways is by using our greatest common factor. So if we want to take the fraction 6/9, we know that it is not simplified, it is not reduced, because they have a factor in common that is greater than 1. So you can list your factors of 6 and your factors of 9, and then by finding the GCF, that's what they have in common. So you can divide both the numerator and denominator by that, and that will simplify and that will reduce your fraction. The great way, or the great thing behind this method, is it does ensure that as long as you find the GCF and you're actually dividing by the greatest of those common factors, you only have to divide once, and then you are done. You have your simplified fraction. The other method is by using repeated division. So if you don't want to find the greatest common factor, you can just find a common factor, so basically something that both your numerator and denominator can be divided by, and you just keep dividing until you can't any further, or until there's no other common factors. So in this example here, they noticed that both 8 and 24 were even numbers, so they divided by 2. Still both even numbers, divided by 2. Still both even numbers and divided by 2. So this one does sometimes require multiple steps, multiple forms of division, but you don't have to list out your GCF. That's why there's not really one, perfect method or one favorite method. It's just whatever works best for you personally. Because in this example here, if you had noticed that the 8 and the 24 had 4 in common, you could have started off and divided by 4, and that would have just jumped you right to 2/6 and then divided by 2 again. Or if you had noticed that the GCF was 8, you could have divided by 8. So lots of different ways, but the biggest thing to keep in mind is the way that you simplify or reduce fractions is you divide by common factors until you can't anymore, until the only thing the two numbers, the numerator and denominator, have in common is a GCF or a factor of 1. And then that lets you know it is in simplest form. All right, let's head on over to IXL and do some problems together, because I know that's where things can really start to click in, is when we begin to do it together. All right, here we are on IXL. And remember, our assignment is 5EW, right fractions in lowest terms. A couple quick reminders. Remember that IXL has help videos built in as well, and also basically like a textbook version, learning with an example. So after you watch this video, if you would like to see some more examples or maybe hear it from a different point of view, check this out, because IXL has some great resources built in already for you. All right, let's look at our first example. So we want to write the fraction 2/8 in lowest terms. Let's use the repeated division as our way of solving this problem. So if we look at both 2 and 8, the first thing I always look to see is, are they both even numbers? Because if they're both even numbers, then I know for a fact I can at least divide by 2. So we take our starting fraction here. They're both even numbers, so I'm going to divide the numerator and the denominator by 2. It is key that you do this for both the numerator and the denominator, because that's what keeps this fraction equivalent. That's what keeps it equal, is because we're doing the same thing to the entire fraction. So it keeps it to where it still represents the exact same amount, the exact same value. It's just been reduced. It's in a simpler form. So 2 divided by 2 is 1. 8 divided by 2 is 4. And now if I look at my numbers 1 and 4, they're not both even numbers, so I can't divide by 2 again. And then if I think about my factors, the only factors of 1 are 1 and itself 1. And then the only factors of 4 would be 1 and 4, and then 2 and 2. Only thing they have in common is 1. This is my answer. This is the simplest form or the lowest terms. So then you can just enter the 1 and the 4 into your fraction here and hit submit. All right, now we want to rewrite 3/6 in lowest terms. Let's do this one by using the GCF method. So if you're using the greatest common factor method, then you're going to take both your numerator and your denominator and list your factors. So my factors, remember those are two numbers that multiply together to equal 3. Well, in this case, all we have is 1 and 3 because it's a prime number. The only factors are 1 in itself. Now, if we list our factors of 6, we have 1 times 6 and then 2 times 3. So the greatest common factor here, well, they have a 1 in common, but the greatest factor they have in common is 3. So that means we can divide our fraction, we can reduce it by 3. So we have 3/6. We're going to divide both. I don't know why it doesn't want to keep the dots for my division there. Sorry, guys. The numerator and the denominator by 3. 3 divided by 3 is 1. 6 divided by 3 is 2, giving us the simplest form of 1/2. And because I used the greatest common factor method, I don't have to worry about double checking to make sure that there's nothing else in common because I already did that. I picked the greatest factor, divided that by that, so I can feel confident that it's 1 and done. All right, let's check out this problem. We have 4/19. All right, we can, look at this a couple different ways. We can use either method here. Let's go back to our repeated, division method and use that as our way of trying to simplify this. So I have 4/19, and I see that they're not even numbers, so that means I cannot divide by 2. That's not an option. The next thing I look at is 3. Well, I know 3 can't go into 4, so that's not going to work. How about 4? Well, 4 and 4 works, but is 4/19 going to work? Nope. I can't take 19 and divide it by 4. If I do, I'm going to get a decimal, and I'm looking only for whole numbers. That doesn't work. How about 5? Well, 5's works if your numbers end in 5 or 0. This doesn't. I'm now starting to get to numbers that are larger than 4. So maybe none of these work. All right, well, let's check out the GCF method. See if maybe there's, something I'm missing. So if we list our factors of 4, we have 1 and 4 and 2 times 2. That's it. Now, if I list my factors of 19, we have 1 and 19. Is there anything else? No, because 19's prime. I don't have any other factors. That means the only thing these have in common, and I was stuck when I did repeated division. Then I switched on over to GCF. The greatest thing they have in common is 1, which means this fraction is already in lowest terms. This fraction is already as simplified as possible. So we're just going to write the exact same thing in as our answer. Because if we divided by 1, I'd still get 4/19. And we got it correct. Awesome job, guys. So do be careful for that and be on the lookout. All right, let's do 2 more examples together. We'll do one more with the GCF method and then one more with the repeated division method. All right, here I have 5 and 15. Let's solve this problem by the GCF method. So I'm going to list my factors of each. So 5 is just 1 and 5. Any other factors? Nope. Lucked out again, another prime number. How about 15? Our factors of 15 are 1 and 15. And then 3 times 5 is also 15. What is the greatest of these common factors? Well, they have 1 in common, but they also have 5 in common. That means we can reduce by dividing by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Here's a cool thing that I want to show you, and you've maybe picked up on this pattern. Because multiplication and division are opposites of each other, notice that when we divide by 5, it's the other half of our factor pair. How cool is that? So it's kind of like you've even actually already done the division when you list your GCFs out. Might be a little time saver there for you. All right, let's check out one more problem together. All right, so let's do this last problem here by using the repeated division method. So I'm going to take my fraction 15 over 18 and look to see what they have in common. All right, first thing I look for is, are they both even numbers? Because if so, I can definitely divide by 2. And they're not even numbers. So let's try 3. Are they both divisible by 3? In fact, they are. So we can start there. So 15 divided by 3 is 5. 18 divided by 3 is 6. All right, anything else that 5 and 6 would have in common that I can divide both of them by? No, because 5 is prime. That means it's just 1 and 5. And 6 isn't divisible by 5. So that is it. Sometimes the repeated division, you only actually have to do it once. All right, for my final reminder before we close out, remember that some of these fractions you're going to get may be like that problem we got a couple times ago, where it is already simplified. So if you are unable to find anything else in common other than a factor of 1, that might be it. It maybe already is simplified. All right, now it's your turn to hop on IXL and try this. Remember, there is a video that IXL made if you want to watch for more examples. But otherwise, I think you got this. If you have any questions, send me an email, or of course, you can come to a help session. Bye.